Hello, my name is Arnaud Soulier and I teach ICS cybersecurity. This is my second video on ICS cybersecurity patching, so if you haven't watched the first one yet, please click here and go see it first. In this video, I want to have a more optimistic vision on security patching for ICS, and to do that, I will explain a new methodology for patching decision. Patching decision refers to the decision to patch or not to patch and with which urgency. Usually in IT and also in ICS, we use CVSS scores, but that can be quite hard, and that's what I'm more confident in a new methodology that I discovered. At the time it was called TEMSL. It was in 2019 at the S4 conference in Miami. There's a recording of the talk presenting this new methodology, so again, please click here if you want to learn more about it. Since then, the methodology was updated slightly, the concepts are the same, and the name was changed. So now it's called SSVC, Stakeholder-Specific Vulnerability Categorization. And the main principle is the same. You rely on decision trees to decide whether you should patch or not. Well, a decision tree is like a flow chart, and you take decisions, and depending on your choices, you have different outcomes. In this methodology, there are four different outcomes. And the four outcomes, they correspond to what you should do about the vulnerability. The first one is defer. That means you will not apply the vulnerability at the moment. The second one is schedule. That means the vulnerability will be patched in the next planned cycle of security patching. So in a lot of industries, that's not on a regular basis, or at least not on a very frequent basis, maybe once a year, but there's no urgency. The third possible outcome is out of band. That means the vulnerability is quite important. I am at risk and I do not want to wait a few months to patch, so I will plan a specific time frame to apply the vulnerability. And the last possible outcome is immediate. For this one, it's in very specific cases. Let's say there's some kind of worm that is spreading all over your internal network, so the exploitation is very widespread. You know that you are vulnerable, the components are exposed to external network, and so basically there's a big risk and you do not want to wait, you have to patch as soon as possible. To decide which of the four possible outcomes it will be for the vulnerabilities, well, you use the decision trees, and there are some different key points that you need to check. The first one is the threat. It refers to the state of the vulnerability. Is it actively exploited? Is there a proof of concept or not? After that, you have to think about the exposure. For example, if the vulnerability is on a PLC, the exposure from a network point of view, it's probably less than the exposure of a remote access gateway. So that's a very important component of the patching decision, the exposure of the vulnerable devices. After that, there's utility. Utility is, I would say, a more complex one. The idea is how useful would this vulnerability be to an attacker. For example, if you have a PLC, I'm again taking the example of the PLC, but let's say you have a PLC, there's a information disclosure vulnerability. It's probably less useful to an attacker than a vulnerability that will allow him to, for example, change the logic of the PLC. So it's linked, I would say, both to the technical impact of the vulnerability, but also maybe specifically on your ICS and the specific use case for your component in your industrial site. Lastly, the last point to decide is called well-being and mission impact. So it's an even more complex concept, I would say. Well-being refers mostly to the safety impact of exploitation of the vulnerability, and mission impact, let's say this notion is about what would happen to your process. Is it essential mission fail? For example, your process will be shut down completely, or you will maybe produce something that doesn't at all fit your requirements. The product will not have the expected quality. Or is it something that will be crippling the mission essential functions? So for example, I will still be able to produce, but not at the same rate, or not with the same visibility, or maybe no impact at all on the safety or my ability to produce. So using those 4 decisions, you will find one of the 4 outcomes. So it's really more simple than CVSS. It's also more, I would say, contextualized to your specific ICS. And I'm really confident that this methodology, maybe you need to adapt it slightly for your specific use case, but it's, in my opinion, easier than CVSS, and it's easier to involve people from the operations in the decision than for CVSS. So now what we will do is try to use this methodology on a sample of recent ICS cert advisory and see what we would do in a standard ICS environment. Okay, so now I'm connected to the ICS cert website here, and I will take a look at some of the advisories. And on the other side of my screen, I have the SSVC methodology open, and this is the decision tree for the patch applier. And so as you can see, it's quite big, and the first criteria is the exploitation. Since I do not have any information about possible exploitation of the vulnerabilities that I will try to evaluate, because I'm not subscribed to any threat intel feeds, and I didn't do any additional research to know if there are proof of concepts available, I will simply, for the sake of simplicity during this video, consider that the exploitation is none. Okay? So that will ease the process, but in real life, of course, your decisions will be very much different if there is an active exploitation of the vulnerability. So now I can maybe zoom in a little bit here. Let's see. Okay, here we go. That should be all right. So for the vulnerabilities, I decided to pick and choose a few vulnerabilities from Schneider and Siemens, because those are 2 major players in the automation world, and I know some of their products. So let's start with this first advisory. So it's on Siemens C-numeric Edge. So I really do not know this device. So I took a brief look at Siemens website. So apparently it's a combination of hardware and software, and it's for production support and optimization. Okay, so take a look at the vulnerability. The CVSS score, it's 7.4. It's in red. And if we look at the vulnerability overview, we see that there's a problem with the certificate validation. Okay, so first, my gut feeling. This is probably not required for production, because they mentioned production improvement. And it's an edge device, so probably connected to the internet. So I would probably patch that quite quickly, because it shouldn't impact the production too much, and it's quite exposed. So I think that this is something I would patch. But let's try to apply the methodology. What is the exposure of such a device? I would say open, because it's an edge device, so maybe it's not directly exposed to the internet. I think that if things are done correctly, probably only outbound connection, but still it's a very open system. What would be the utility for an attacker? I would say that the utility would be between efficient and super effective, because even if it's only a monitoring system, it's probably connected to all the devices on the shop floor. And then what's the well-being and mission impact? Well, this solution, again, I'm not an expert, so I'm taking some assumptions, but if it's a production improvement and efficiency optimization, it's probably not required, and there's probably no safety issue about this. So I would say that I will consider that it's efficient and the well-being and mission impact is medium to high. So here the methodology says schedule. So as you can see, using the methodology, the result is a bit different from my first impression. I would have said I would patch that quite quickly, but here it says scheduled. Scheduled can mean a lot of things depending on how you use this methodology. It could be maybe once a month, could be once a year, depending on your ability to patch. But that's a first example. Let's take a look at the second one. The second one is a very high vulnerability, 9.8 CVSS score, so that's out of 10, by the way. And it concerned the thematic ITC. So again, I took a look. Thematic ITC stands for Industrial Thin Client. So basically, it's an HMI that will connect remotely to a server to access some kind of SCADA or process supervision and control. And if we took a look at the vulnerabilities, they affect the libVNC vulnerability, and that could allow remote code execution. So really, it's almost as bad as it gets. Somebody could exploit that to gain access to the device and do whatever they want with it. Okay, so here it's a bit difficult. My first impression would be that, of course, it's a bad vulnerability. And we need to patch it probably, but let's take a look at the methodology. So again, I'm considering that there is no exploitation. What is the exposure? Exposure of the system is probably small. The system should be composed, if I understand correctly, of those thin clients that would be installed as HMI in the process and maybe a central server somewhere. But here, in my understanding, this only applies to the thin client, not the server themselves. So it's probably, yes, a small exposure. Utility would be efficient to super effective, because if you have access to the HMI, you can control the process. That's the way it works. So, and since it's remote code execution, that pretty much means that you can access the device and do whatever you want. So it's probably super effective. Then what would be the well-being and mission impact? Well, it's probably going to be high, I would say, because if you have access to the HMI, you can probably mess a lot with the process. Maybe it's not a mission failure. It's probably not a safety issue, because those systems shouldn't be involved in safety. But I would rate that to high. And then again, sorry, let me see. Small, I said super effective, and then medium to high. So the result again would be scheduled. So scheduled is there's no urgency. I will patch the next time. I will patch everything. So that seems on par with what I would do on the first impression. Okay, last one for Siemens, TIA portal. So TIA portal stands for Totally Integrated Automation, and basically it's the software that you use if you want to program Siemens PLCs. CVSS score is 7.8, so it's quite high. And let's take a look. Okay, the vulnerability is improper limitation of a path name to a restricted directory. Well, basically that means that if you are a legitimate user of TIA portal, you can become administrator of the system. So it's a privilege escalation, and I would probably not patch that. Why? Because only a few people should have legitimate access to TIA portal. You should have, I would say, quite a good trust in those people. And well, if you have access to TIA portal, you can program the PLC. So being able to get system access, okay, it may be useful to an attacker that want to spread across the network or maybe install some additional hacking tools, but you can already have all the impact that you want on the PLCs that are connected to this engineering workstation. So definitely I would not patch that, or maybe in the next cycle, because that's easy to do, but no urgency. Let's take a look. So again, no threat. Exposure is probably small. The engineering workstation should be part of the core of the automation network, shouldn't be exposed to any third-party network. And then What's the utility? Well, my evaluation would be laborious because you do not need this vulnerability to be able to do anything. And however, the well-being and the mission impact could be quite high because some of the PLC, if you can reprogram the PLC, it might have an impact on safety, and definitely it can be a mission failure because you can stop the process or mess in a lot of different ways with the process. So I would say it's high to very high, and so the result would be scheduled. So of course, you apply the patch the next time you apply the patches, but no urgency. Well, my demonstration is maybe not that good because everything is scheduled, but one thing I get from this methodology, and I think it's on par with what I had in mind, is that at the moment we took a look at only a few vulnerabilities, but with high CVSS score, and the decision is to do nothing at the moment. So I think it's on par with my previous video where I was challenging the necessity to patch everything all the time. Okay, let's move on to Schneider. Schneider Electric IGSS. IGSS is a SCADA application that is sold by Schneider Electric. CVSS score 9.8, so that's really, really high. Okay, let's take a look. And okay, what's affected is DC.exe, so that's one component of the SCADA, and it's the data collector. So basically it's the process that's in charge of discussing with the PLCs and discussing between the SCADA HMI and the SCADA servers. Okay, so that's a very important component. Then let's not dive in too much into the vulnerabilities. From a technical point of view, buffer overflow, it's pretty bad. Missing authentication for critical function, that's kind of like a forever day. So it's not really a vulnerability, but more like a bad feature. So that's pretty bad. Okay, so let's say there is no exploitation. The exposure of the SCADA, I mean, in an ideal world, it should be small, but I usually tend to say small only for the production network, so the PLC, low-level devices, and maybe the SCADA in some context could be controlled. So that means some part of the SCADA could be exposed because, I don't know, the network is connected to the DMZ to exchange some data. So it really depends. Here I will say it's controlled, but in your specific case, it could be small. What is the utility? Well, if I do not need any prior information and I can exploit a buffer overflow to get access to this data collector component, I can then exchange data with the PLC. So I would say that the utility is probably super effective because once I am here, I can directly send commands to the PLC. So that's quite interesting. And the well-being and mission impact, in my perspective, it's not very high because this doesn't allow you to reprogram the logic of the PLC, so it shouldn't have an impact on safety, and it can have, depending on the type of process, I would say it could be a mission failure if you rely on SCADA a lot. If your process is more autonomous and you can run without the SCADA, it's probably not as high, but let's say anyway, high or very high, the result is scheduled. So there again, there is absolutely no urgency. I'm not going to patch that. I'm just going to say, okay, I put it on the top of my vulnerability patches pile that I will deploy the next time I patch everything. So probably during the next maintenance shutdown. Okay. Let's take a look at another one, again from Schneider, CVSS score 7.8. What are the products? So the first one used to be called Unity Pro, so it's the software to program the PLCs. The second one, Process Expert, is DCS. So it's a bit complex because a DCS it can mean, I would say, the supervision part, so the equivalent of a SCADA, but as part of the DCS, you also usually include the controllers, which are more like the PLCs, so that could mean a lot of things. And SCADA Pack Remote Connect is a tool, I made some research, apparently it's used to program some RTU, so it's not a remote access software, in my understanding, but it's mostly to program RTUs. Okay, and here the vulnerability, what does it says? When a malicious project file is loaded on the engineering workstation. Okay, so what does that mean? It means that you already need a first access to this workstation, and again, that may allow you to get additional privileges. So it's really similar from my perspective from the TIA portal vulnerability, I think. So let's take a look. Let's say there is no threat exposure of this vulnerability. So it depends if it's the whole DCS or if it's more like Unity Pro, it's the engineering workstation. So I will consider that this is the engineering workstation. So exposure should be small. Utility would be super effective. If I can get access to that, I can do a lot of things to the PLC. And the well-being and mission impact would be high to very high. So again, scheduled. Okay, so we took a look at 4 to 5 examples. I was not able to find one that required, I would say, immediate patch. And again, that seemed just right to me because over the course of 1 year, there's maybe 1 or 2 vulnerabilities that need an immediate patch. And then it's probably a Windows vulnerability, not an ICS software or ICS hardware specific vulnerability. So I hope you liked this video. I'm really confident in this new methodology. What's also interesting is that the exposure, the utility, and the well-being and mission impact, they are calculated, of course, depending on some aspect of the vulnerability, but a big part of this aspect is also directly taken from the asset inventory. I mean, the exposure of the device is not something that you have to evaluate each time. It could be a specific tag in your asset inventory. So that could also lead to faster time for patching decision because the exposure and the well-being and mission impact of the devices could probably be part of the asset inventory. So that would be a very interesting idea to perform some research and try things out. How can I automate the vulnerability patching decision by leveraging all the information I have in, on one side, the security advisory, and on the other side, my asset inventory. And I'm quite sure that this could lead to less time spent deciding what to patch and what not to patch. Thanks for watching and see you soon.